Ladies and gentlemen, please welcome our next speaker, Francesco Sciuti, presenting the topic, We are all good with browsers made by others.
Hello everyone. Thank you for being here. I'm a bit nervous, so let's dive into the topic. We will take a quick ride through the tool we use the most, our trusty browser. Okay, it helps everyone surf the web, but more importantly, surf our artistic creation. Well, but first, let's have a show of hands. Are you ready? Yeah, okay. Are you ready? Oh, great. Oh, if I asked all of you, how many times have you gotten frustrated with your browser not responding? And? Well, a lot of hands. Well, every day. Okay. How many of us have said the F word during web navigation? All of us. Okay, I'm sure. And I often have you seen or caused a page with laggy animation or a bad user experience? Great of fonts. Okay, thank you for your residence. And it's time to understand why our dear and beloved browser sometimes acts like this. Okay, we will try. Okay, but what is what is a browser? Everyone uses it, but only some really know how it really works. Okay, so let's start by learning how it works and what challenges it might face. Well, if we try to simplify things, a browser is an application that requests data from web servers, right? Sends a network request to the URL and retrieves resources and presents them interactively. Sounds simple, right? Trust me, there's nothing simple about it. It's one of the most complex processes you can imagine. Okay, a browser is one of the most used software because everything is web-based today, and they are built with millions of lines of C++ or hardcore languages, and it is not a good news. They changed a lot over time, and because users' needs changed over time, and trust me, another time, they are a concentrated mix of technologies and algorithms, which makes a Batmobile looks like a regular car. Okay, and trust me, I'm a Batman enthusiast, so it's very difficult to say something like this. Okay, well, but who write browser have a little chaos to manage. Users love to see pixels on the screen as quickly as possible. Do you agree? Which is the reason why the browsing experience is enjoyable. So if you have pixel happy, you will be happy. You will have an enjoyable experience. But you might be thinking, well, why I should care? It is an Italian gesture, very common Italian gesture. I'm not a browser code developer. A little disclaimer, if any of you are from the Chromium team, for example, please be merciful. I'm trying to understand better how a browser works. Okay, please be merciful. Okay, so it's not a problem. As web developers, we must understand some of the mechanics of browsers to make better decisions and make sense of some things that sometimes seem absurd. This is not a so famous quote because it's mine, but I hope it will be. And it is from Ciccio from Valdemone. Valdemone is an ancient name of the region where I was born, and it is a very cool name in Italian language, so it's beautiful. Okay, it's a complex stuff, okay, and but worth knowing about, so we can try to dive into how it's built and a look a bit into its architecture. Okay. Currently there are no standard architecture or specification to build a browser, and approaches could change from one to another. And the most commonly used today architecture is a multi-process architecture, where each process handles a specific task or logic. And it's important to understand that each process has a main thread and a lot of other dedicated threads, for more specific tasks. Okay? Yes? Okay? Yes. Okay. To get a clearer understanding of the concept of processes and threads, okay, we can define them at a level. I'm sure you know this concept, but it's important to remember. A process is like a running program that includes executable code, data, or the state of our application and other elements useful and required for the execution. Each process has its own address space, and it is managed by the operating system as an independent entity. Okay? On the other hand, a thread is a single unit of execution within a process, and a process can contain one or more threads that share the same space, the same memory space and resources as the parent process. Okay, I'm sure you know this concept, but it's important. We are talking about a multi-process architecture, so processes must communicate among them, and the way is IPC, a set of mechanisms and techniques like pipe, for example, or sockets, shared memories, and so on, that enable separate process exchange data or information for work together. Okay, IPC is essential when coordination and sharing of information are required. For example, in a multitasking application or a distributed application, and so on. Okay. Well, so a browser is a multi-process. Okay, a multi-process architecture or application. But what exactly are these processes, and how do they collaborate among them? He is tired. Okay. Don't be scared. Okay, it seems complex, and it absolutely is, but this wonderful and beautiful diagram helps us. Okay, a browser is divided into various processes. The first one, the main or browser process, and it is the primary process for our architecture, and it is responsible for managing the user interface, the address bar, menus, tabs, and so on. And it is useful to coordinate the interaction among other processes, okay, involved in this architecture. And it is also handles the creation and termination of tab rendering process. Okay, now it is the next process. So rendering process, the browser process, we can imagine it as the blue rectangle. Okay, well, the next one, render or rendering process. Each open tab during our navigation in the browser is associated with a separate rendering process. Okay, it is very important. This process renders web pages, process HTML, executes JavaScript and so on, interact with the DOM and so on. And the very important thing to know is that each tab has a dedicated process. Okay, it is a very high level definition, but it is good enough right now. The next one, network process, that manages all network stuff, including resource downloading, for example, images, scripts, style sheets, and so on. And it isolates network operation to ensure that security issues or crashes don't impact our browsing experience, so the entire browser experience. Okay, so it's basically responsible for communicating with the network, okay, and manages this stuff. The last one is the GPU process, that is like a layer between our browser and bare metal, the GPU. So it is useful to manage the hardware acceleration. Okay, it is very important. Okay, great. Each process has a priority, and a priority show how is important a process to the underlying operating system. The operating system uses this priority to balance resources, okay, our resources of our machine. Okay, well, okay, like everything else, a multi-process architecture has its pros and cons. We are lucky because pros are more than cons. And the first one is sandboxing, and it is like a security bubble that isolates processes, okay, and the to the underlying operating system. And so if one process is afflicted by malware, for example, the damage is contained inside this bubble without compromising the whole browser experience, okay, and the operating system experience. Okay, then the next one, black sheep detection. It is a very cool name for me, black sheep detection. Okay, consider it like a way to spot processes that are consuming resources like memory or CPU, and this feature prevents that a single tab from destroying the entire browsing experience. Okay, privacy feature can ensure that sensitive stuff like cookies, session info, and so on are handled. I'm sorry, securely and privately. Okay, and the last one, site isolation. Web pages. It ensures that web pages from different sites load in separate processes. Okay, there are some cons too, but we are talking about multi-process architecture, so it's normal that we had a lot of processes that use memories and need to communicate with IPC. Okay, so this overhead, it's normal, okay, but it is managed. Okay, so what's happened when we browse? When we enter a URL or a query in the address bar, the input is evaluated by the browser process, and then it communicates with the network process or thread, depends, to execute the request, and the response is read and handled. Okay, at this point, a render process is activated. Is activated. Okay, and the navigation is taken over by the render process. Finally, the document loading phase begins, and it maintains the dialogue between the render process and the browser process. Okay, well, a very beautiful and animated slide. So the users, a user types in the address bar, and the browser process asks to the network process to go fetch the information over the internet. Once it is received, the browser process creates or look for the best render process, which communicate with the browser process, and tada, our page is served. It's not magic, and we can ask what happened inside the rendering process. Okay, easy. The rendering path is the most intricate but exciting part of our journey, and it is where we encounter the much feared critical rendering path. Okay, here's the entire journey that the rendering process has to do to render a single frame of our page. Okay, so it is the journey for a single frame, but the rendering of a page is like a cartoon. It is rendered frame by frame. Okay, it is the journey for a single frame. Well, it is another gesture, Italian gesture. Do you know Italian gestures? Oh yeah. Okay. Well, scared? Okay. Let's remove the expression of terror and take a look inside. Inside the phases, the steps that the rendering process needs to handle: parsing, style calculation, layout, paint, compositing. Okay, let's go through them one by one. Well, data, the first one, parsing. Data travels over the internet as packages. Okay, and when retrieved by the network process, the data is nothing more than raw bytes. Okay, the first thing we receive is the HTML, which is also received as raw bytes, simple bytes. Okay, here the parsing step begins. This step transforms the bytes into a series of characters, like a unit of a string. Okay, and then these characters are tokenized. Tokenization means converting this sequence of character into a sequence of tokens. Okay, a token is a piece of text representing an HTML element or an attribute, a text, or other content within the HTML document. For example, an opening div tag becomes an opening token, or a closing div tag becomes a closing token. Okay, so we can obtain an analyzable structure, and the tokens are analyzed by the lexer, a lexical analyzer. Okay, and and it is useful to discover their type and structures. Okay, and so such, for example, tag name or an attribute value, and so on. So the lexer analyzes the token stream to recognize their structures. Okay, finally, browser can create nodes and the relative DOM, the document object model, using the extracted information during tokenization and lexer works. Well done. I'm sure you know what is the DOM. Okay, it is the first step. The second one, after creating the DOM, the browser build another free-like data structure called CSS-OM, and it represents all CSS rules declared in our document, including selector, style declaration, or specifiety. Okay, it uses similar techniques as the previous step. It's not the same, but it is similar. And this step fetches CSS style sheets and relative files and extract inline styles directly from the HTML document. So CSS is parsed to create the CSS-OM. So finally, this phase is completed. It's similar to the previous one, and the process is ready to create one of the most important data structure for our browser. Once the DOM and the CSS-OM are created, the main thread traverses through the DOM and styles, making this data structure called layout or render tree. Okay, this tree contains information such as the coordinates and the dimension of the elements. The layout process, so this step requires a lot of browser resources because it has to compute the exact position and size of each element of the page. So it is a slide I'm very proud of. It's contain a remarkable quote. I hope you will appreciate it, and I'm expecting a huge applause. Okay, please. Okay, the DOM and CSS-OM fusion. Thank you, Toriyama. Okay, we have obtained the most powerful layout tree. Where is the applause? Oh, thank you. Okay, to build the layout or render tree, the main thread will have to recursively traverse the DOM and search for the visible elements, only visible elements. Non-visible element is not so useful for this step because we don't need dimension and position for a non-visible element, and build and update the layout tree and their node by pointing to the DOM node. So create a relationship of each tree layout tree node and DOM node. Okay, and then derive the computed style for the DOM node and associate them with the layout tree node. Okay, so gathering this information in a single structure, thanks to gathering this information, our elements are positioned on X and y-axis, like a 2D position, okay, 2D coordinates. It is very important, okay? And it is the layout step. I hope this video is clear enough to have an idea about how much work is required. Yeah, thank you. Ooh. Only 15 minutes. Okay. Well, a lot of work to do. Okay. So we have positioned the elements on the z x and y axis, and the new step comes into play, the painting step. We know the dimension and position of the elements, but it's also necessary to know how the elements are arranged on the z-axis, okay, the third dimension. So what's in front and what's behind? During this phase, the layout tree is traversed, and to build a queue of paint records, that are like a deck of cards, useful to detect pixel colors, for example, the drawing order of the elements and their overlapping, okay? So what's in front and what's behind. This step is when the browser detects pixel on the user's device, but detects, not render, okay? Well, the last one, the compositing phase or step. During this step, browser creates the final visual appearance of the web page, okay? And it is a technique to layer parts of a page, rasterize them separately, and composite them as a page, okay? It's important to know that this step is executed out of the main thread, and it is very important. It is handled by an independent thread. Can you hear me? Okay. Called compositor thread. Okay, and it manages a lot of intensive operations like scrolling. Okay. Well, during this step, the content is divided into layers. This representation, so the page is split to into a lot of layers, okay? And to generate, the layer tree. So the main thread sends this information to the compositor thread that handles the rasterization of each layers, okay? The compositor thread also divides our page into panes like a square. You can see the gray squares, and so divide our page into panes and send each square called draw quad. The name is draw quad to raster to the raster thread, another thread useful for the rastering. Okay, so this information is gathered, and it's time to create a compositor frame. So it is a collection of this information, all information. Okay, so this compositor frame is sent to the browser process and then to the GPU to rasterize our page, also to render our page via IPC. Okay, the compositor thread has another work to do. If a browser process receives a user event like click or touch start, send the event type and the relative coordinates to the render process. Okay, so the render process manages the event if there is an attached listener and run it. Okay, but it's important to know that compositor thread makes and associates the handlers to some areas of our page called non-fast scrollable regions. If an event occurs outside these regions, the compositor thread can create a frame without asking anything from the main thread. Okay, so can skip this kind of request. Okay, and it is a very good improvement. Okay, there is a lot of stuff to do, and every step is crucial. This journey is called critical rendering path, and why is it is called critical? The browser must create frames at the device refresh rate. So it's fundamental that a browser renders about or almost 60 frames per second to ensure a smooth animation and a good user experience. So the entire pipeline we saw has approximately 10 milliseconds to complete its task. That it's not much time. Well, okay, so it's critical. Well, if the browser fails to maintain this frame generation frequency, we will see infamous lags called junk, but no user wants a poor experience, so avoiding it is crucial. Well, we have some good news. It's important to know that we can skip specific steps like layout and painting using some optimizations. You can skip the layout step when dimension or positions aren't changed of each element, aren't changed. Okay, for example, if only the color of text changes, probably the render process skip this step. Okay, and it is another very good improvement. You can skip the painting step using specific CSS rules like transform or opacity, and it is another very good improvement. I have no time. Okay, so it's clear that skipping any of these phases or steps will help the browser to render a correct number of frames for a good experience, a smooth experience. Some clarification. Web application use the main thread to execute the application logic and code, but the main thread executes also user interface tasks. Okay, so I'm sure you know what is the event loop, but it's important to understand that it lives within the main thread, and the good performance of the event loop determines the good performance of our application. Okay, well, it is a high-level representation of the event loop. It's very good. Okay, but I have no time. Basically, an event loop is an infinite loop, and it is responsible for selecting a task from the task queue and place it on the call stack for the execution. Okay, but sometimes select a render step task instead of reading from the task queue. Okay, and it is useful to generate a new frame, and we need 60 frames per second. Okay, so we need to be careful and not overload it. Okay, there are very different type of tasks, and for example, HTML or CSS parsing, input element. Okay, input event management and network data and render step. Okay, Oh, I hope uh, I hope it's a bit clearer now, but I hope we understood that the browser has to render a frame a lot of tasks. Okay, and but it's important that browser reaches the famous 60 frames per second. Okay, well, we talked about a Chromium-based architecture, but it's important to remember that on the market we have a lot of JavaScript and rendering engines. Okay. Our browsers don't have such an easy life as we could think. So it's a good idea to start thinking about how to make their job, more manageable. Some stuff we can use to reach this goal. Some techniques. Please, we need to use request animation frame and request idle frame. The second one is not so famous, but it is very important. Okay, idle time is a very important time for our browsers. Okay, you can use will change CSS rules to split a layer. Okay, between the painting and compositing steps. Okay. Oh, okay. I'm sure you use async or deferred tags attributes. Please, we need to use workers, because workers is useful to execute code out of the main thread. So it is the goal. Priority resources, and please check CSS and API triggers for skipping layout and painting steps. Well, ta-da. Okay, to ensure a smooth experience, let's try to help the tool that helps us to navigate through billions and billions and billions. It is another quote. I don't know if you catch it. Of pages full of things to learn and kittens every day. Oh, okay. Do you love kittens? Oh. Okay, I do it in my way. I use the bad computer. Okay, which is powerful, and I don't care. I'm kidding. I'm trying to write better code. Okay, it is my sweet for the night. Okay, a collection of links to learn these topics. More. I'm Francesco Sciuti. Thank you so much. I'm a developer by choice and passion. I'm a Google developer expert and a Microsoft MVP, and I love nerd stuff, especially Batman stuff, and I love to share knowledge. So I'm also a partner in an Italian company focused on front-end and mobile development and training about these fields. Thank you very much. Here are some links to reach me out if you want. I hope you want. Thanks again. Thank you so much. And it's feedback time if you want. Thank you. Dai. Okay. Oh. Feedback. Oh, yeah. Oh, I showed the render animation of a web page with various color. Is each color a different thread? No, pixels are detected in the paint step. Okay, so the paint step lives within the main thread. So no, the only one thread that manages pixel colors are the main thread. Oh, not so much, because we talked about what happens into the browser. So you already received the page. So yeah, okay, or better. If you have less JavaScript to manage, it's a good thing to have. So yes, the server rendering could help us, but everything helps our browser to skip, for example, steps, or to improve and reach the famous 60 frames is useful. Não chegou a... What is? Okay, we need almost 60 frames per second because but is better than the refresh rate is similar to the render frequency, but 60 frames per second is good enough. Okay, and yeah, merciful. Have all three browser engines converged on a similar multi-process architecture? Oh, a moment, I'm too old to read in that way. Have all three browsers engine converged on a similar multi-process? Okay. If I understand the question, there are some render engines. I talked about Blink. That is the render engine of the Chromium architecture, okay? But there are Gecko, for example, or I don't remember the last one used by Safari. But yeah, we have similar architectures, and it is commonly a multi-process architecture, okay? So I suppose that the engines are similar. Yeah, maybe. It is a very good question, but I don't know the answer. No, I'm kidding. Yeah, GPU and WebGL are useful, but it is a different it is a different topic. For example, WebGPU is very important because it enables to dialogue directly with the GPU. Okay, so probably the render engine will move to this direction, but I don't know. WebGPU and WebGPL are APIs, so it works like APIs. Okay. Yes, WebGL, for example, is an API optimized for the rendering, for sure, and it works, for example, on the canvas tag. Okay, so it is an optimization for the browser, and it is an API, a browser API, okay, a web API. Okay. Okay, thank you so much. Bye bye. Oh, if you want, I have stickers and pins if you want.